All right. We have people rolling in.
Woohoo.
Yes, woohoo.
Oh, that was one of the things I used to set up the interface too, so that I could see who was here.
See the people?
But
Yes.
but I'm not going to do that today. I'm I'm not used to this interface enough anymore to really want to have 5 different things open at once.
Oh my gosh. And it might be even a little different than when you left. They updated it at some point, so it looks
Oh,
more like a Zoom or something.
yeah.
Okay. All right. Here we go. 10 o'clock. Welcome everybody to our presentation with our old pal, Shaun Darragh. Old because we've known him a long time, though. Young pal. Um, of SPD Light Studio, UW, and formerly here at, well, the Lighting Design Lab. We'll call it that for just this second. Um, and let's go to the next slide, Shaun. Shaun's going to talk about energy effective lighting design. And here are some procedures for you. If you haven't had a webinar with the lab, or maybe not for a while, you are all on mute for good or for bad, but you can submit questions at any time. Go look for the little icon that's like a text bubble with a question mark. Click on that. You can submit questions at any time there. Shaun's going to save them for the end, so don't stress if you're not getting a reply. The little chat icon, though, is disabled, so don't try to enter anything there. You won't go anywhere. We are being recorded, so this is going to live for forever on the internet. You could share it with your friends, your family, holiday time, or if you need to step away in the middle, this is a 2-hour class, then you can come back and see the spots you missed. There's a survey at the end of class. We love when you take the survey and give us suggestions on what you'd like to see from the lab in the future. Another little feature that I like to point out is, well, it's in my screen, it's the bottom left, there's a react button. If you hit that little up arrow, you've got 5 little reactions to choose from. You can laugh at what Shaun says. He can see you laughing because we can't see your faces, unfortunately. So it can be a little lonely when you don't get any reactions. Thank you, Clement. I have no idea if I'm saying your name right. I am so sorry. I've said it millions of times, but I'm just guessing. Oh, yay. I took French for 1 quarter. Um, so why don't you go to the next slide, Shaun? I'm going to tell you what's coming up at the lab. We've got 5 brutal building envelope blenders that burn builders' budgets faster than a hot knife through butter. I did it. Oh, I didn't. I forgot to put in. We've got another one coming in April. That is a cold climate heat pump. Both those are ready to sign up for on our website. As always, there's a monthly Trade Ally office hours that you can come and talk to folks like Avery that you see on your screen about our incentives. And if you've got lighting projects that you are proposing to customers, or you're in the middle of one, you can get a status update. So that's a good thing to sign up for on those monthly Trade Ally office hours. And then the next slide, I've got some big, humongous news. Oh my gosh. We have, if you've been with us for a while, we've been teasing this for a while. We do finally have a new name, the Lab at City Light, to better reflect that we've expanded beyond, still including beyond lighting, to all the electric technologies, strategies in your buildings. So you'll see this logo popping up now. It'll take us a little while to get everything rebranded. We are in the process of a new website, probably not till May or June, but this is what you'll get used to seeing. And now we've got Avery, the aforementioned Avery. He's going to tell you about our sister divisions. CES is what, Customer Energy Solutions. They've got solutions for you in the form of dollars, a little advising. Avery, take that away.
Good morning, everyone. My name's Avery, and I'm an energy management analyst over on our CES team. And Katie's right. Yeah, we utilize incentive funding to help customers, to help guide customers towards more energy efficient solutions. And so basically, we will pay out a downstream incentive based on the kWh savings, based on either the fixture savings and control savings. And additionally, we also offer bonuses if you're utilizing network lighting controls. There's more information about that on our website, or you can reach out directly to us to get to the real meat and potatoes of it. But yeah, so this is just an example of one project that we led we closed out last year. It was for some back of house lighting at McCall Hall, the Opera House. Basically, they were running T8 fluorescents 24/7 down in the back of house. So not the theater you get to see, but where they actually do like the wig styling and things like that. So they ultimately ended up saving a lot because those lights were on for all year round, and so we were able to give them an incentive of about $2,700 or $27,000. That's a different number. $27,000 because they did utilize luminaire level lighting controls, which we have a bonus for in our downstream program. And if you get the slides later, there's a link to a video case study. You'll probably see a familiar face in there. But yeah, we can hop to the next slide, and I can give basic rundown of how our downstream program works. Y'all are all perfectly capable of reading this, but basically the big take-home info for here is just get in touch with us as soon as you can, because we need to, before any lighting is either demoed or installed, we need to actually have the opportunity to get out there and verify what's going on. So get in touch with us pretty early on in your project so we can make sure that you're taking advantage of as many incentives and bonuses as we have available. And we'll work with you to calculate that incentive. And then once the customer signs that agreement, you do the installation, and then you just give us a shout when that installation is over. And then we'll do a verification, and then there will be an incentive. There will be an incentive check after a whole a fun paperwork dance, because we are a municipality, so there's a lot of paperwork. But that's pretty much all I've got. They're going to throw my information up at the end if you have any questions, but you can also reach out to our energy advisors as well on the email or the phone. All right, thanks.
Yep, and that's a good point. Avery said this is the downstream program. They've got other programs that are point of sale, dollars off lamps and fixtures. So just get in touch with City Light. We will tell you everything that you need to know. The Trade Ally office hours are a good time to do that. And now for the feature presentation, you've got your popcorn and your cola. Shaun, Darragh, welcome back. He has a completely new presentation for everybody here today, so it's very exciting. All right, Shaun, take it away.
Thank you, Katie. Thank you, Avery. And thank you for bringing me back. Appreciate it. My name is Shaun Darragh. Some of you on the call know me. Some of you may not. I am a lighting designer. I've been a lighting designer, it horrifies me to say, for not quite 40 years. My first paid lighting gig was in 1988. Oddly enough, I've done about 35 million square feet of lighting projects on 5 continents. I've tried to focus on ones that you folks might know or have specific reasons for doing so on this particular presentation. But I'm also a lighting educator. In fact, I'm sort of semi-retired from the whole design world, and primarily teach lighting classes, much like this one now. So I like to say that the smallest lighting design project I ever worked on was lighting and controls for 2 Nobel Prize medallions. And the largest was King Abdullah University over in Saudi Arabia, which was a 20-building college campus designed and constructed in 3 years. At one point, every single architect from HOK on the planet was involved in this project. And when it was completed, it represented 50% of the LEED Platinum square footage on the planet. So I have a fair background in sustainable design. And that's been a passion really for my entire life, which is why we talk about energy effectiveness here. If we were in the same room together, this would be the point where I would start to ask all of you some questions about who you are, maybe introduce yourselves. Sadly, we don't have the opportunity in this time, but Katie has been kind enough to send me the registration form. So I have a pretty good idea. We have some lighting designers, some electrical engineers, some salespeople, some utility folks, architects. Some architects that I've worked with are on the call, some architects that now actually work for the city of Seattle. So there's a wide, and I do mean a wide range of backgrounds on the call, which is great. This is actually one of the reasons that the lab has been so successful, is that we try to push information to a wide group of people and let you do with it what you will. So I am going to try my best to do a little look at new construction, retrofit construction, and try to push things around so that I'm answering, hopefully, things that all of you can use in your own practices. So why are we here? As sighted people, if we talk to a sensation and perception psychologist, as much as 80% of all of the environmental information that we process is visual. It comes in through our eyes, right? And that is critical. 100% of that, of course, is light that comes from somewhere, reflects off of a surface. Some of the light gets absorbed, some of the light gets re-reflected, and then it comes to our eyes and gets interpreted, right? So we have visual needs with respect to lighting. There are also biological needs, right? Bill Lamb was a seminal lighting designer back in Massachusetts. He was an MIT architecture grad, and he wrote a really important book in 1972 called The Perception of Light and Perception and Lighting as Form Givers for Architecture. He identified in that there were a number of biological imperatives that we all needed within architecture, most of which, in fact, all of which have some connection to lighting. So his location, where are we, right? Where do we exist within the framework around us? What time is it? Is it morning? Is it night? What's the weather? Is it dark out? Is it light out? Is it snowing? Is it raining? The enclosure. Are we safe? Are we within a particular environment? And can we see that whole environment, right? Other living things, the presence of people. Can we see people's faces? Can we identify people's faces? Territory. That's kind of the bounds of where we are. So we want to be able to see what circumscribes our space, right? Relaxation and stimulation, places of refuge for danger. All of these have implications for how we choose to design and light the spaces in which we find ourselves, right? Now, there's also a great deal more to this than Bill even knew. Today, and since the early 2000s, we've understood that there is a real connection between light and physiology that doesn't have anything to do with our visual systems, has everything to do with our endocrine system, right? Our sleep-wake cycles, our circadian systems, right? So enormous amounts of research are going into this. We've learned a lot. We don't know everything. Unfortunately, getting deeply into this class would really be a bit beyond the purview of today, but understand that it's going on and that research into light and health and light and psychology, physiology is continuing, and it's not new, right? In the 1990s, late 1990s, the Heschong Mahone group out of California did some groundbreaking work on daylighting studies. What they found, and you'll notice that one of the photographs there is the Eckstein Middle School, about a mile south of me right now, that they found that daylighting in classrooms increased test scores, increased productivity, increased user enjoyment in those spaces by an enormous amount. A concurrent study that they ran also found that materials that were in big box retail and other retail spaces that were in daylighted areas outsold materials that were not in daylighted areas. And it didn't matter what the materials were. They switched things around. They put new goods on the ends of display gondolas and all that stuff. So we understand just on the get-go that from a physiological and psychological standpoint, daylight helps us. There's going back even further. There is a study that was done in 1971 by Allsworth and Bridgers. They were looking at unvarying electric light. They're, what we keep hearing about as what we need, right? Well, we need very even illumination. We don't want to have very high contrast ratios, which very high is true. But effectively, what was lighting at the time, the idea was light everything evenly and call it good, right? Some might call that volumetric lighting. We'll talk about that more in a little bit. But what they found was that we need dynamic lighting cues and a connection to nature and the passage of time, which dovetails in really well with what Bill Lamb was saying, right? So one of the test beds that they were looking at was this load control center at a utility in San Antonio, Texas. And if you look at it, apologies for the quality of the photo, it's the best I can get. The lighting for the time seems really good, right? It's pendant mounted indirect lighting the ceiling. So it's very soft, it's very gauzy, but it never changes. There's no variability at all. Anybody that studies things like nature and biophilia or similar fields will tell you that one of the key things that we are really meant to expect in life is change, right? So what they found, and I don't normally like to read slides, but I do love this quote, so I'm going to. What they found was that unvarying electric light can lead to low-level sensory deprivation manifested by impairment of organized thinking, oppression, depression, confusion, suggestibility, and general irritability. Anybody felt that way at the end of the day? So a contemporary lighting design, right, was a luminous ceiling in a kind of interior office, open office plate like this. And you can imagine that the people that are sitting in the middle there, they go home at the end of the day feeling pretty depressed, confused, suggestible, and irritable, right? What about the guys on the left there who have the window walls in their private offices? They're probably feeling okay because they have that connection to variability. Now, the good news is we don't design spaces like this anymore, right? So these are two pictures that I pulled literally this week from advertisements from lighting manufacturers who shall go nameless that, gosh, they sure look an awful lot like this, really, right? The light fixtures are a little different, but basically you've got lights up in the ceiling, you've got no access to daylight, you've got no access to time. And in fact, in the photograph on the left, you see that you've got perimeter private offices. So the people on the side are doing just fine. They're probably okay. But the people in the middle, they're going to have some issues. So we'll see how maybe we can address some of these things as we move forward. So why else are we here, right? This class is actually a bit of an amalgam. Some of you may actually see some images that you've seen before in other slides because there are particular projects that I like to use as examples, either for good or bad, or maybe things we could have done better. And the class and the class format was really requested by a former student and suggested by a former student who I don't think is on the call here today. But what she had asked for was a walkthrough of some examples and practical tips for better lighting that we can all implement, right? What is energy effectiveness? How does human perception matter to this? What about light interacting with surfaces? And example. Now, I'd love to get into the physiology and circadian systems more. Again, unfortunately, that's a whole class unto itself and probably longer than 2 hours. But let's start with the notion of energy efficiency. So Energy efficiency. How do we define energy efficiency, right? We hear this term all the time. Something might be lumens per watt, right? How many pounds of light do we get out of a light bulb for the amount of power we put into it? Or the same for luminaires. How many pounds of light do we get out of a light fixture for the power that we put in? We call that efficacy, right? We might define it, I guess, as candela striking a horizontal plane. That's basically what we think of as illuminance, right? The amount of light striking a plane. And we measure that. Everyone will know the terms foot candles. Some of you will know the term lux, which is basically just the SI unit for that per total system watt. Might be lighting power density, right? We talk about watts per square foot. I'm sure there are other options out there, but if you look at these two images here, one is an incandescent-ish lamp hanging from a socket, right? That is a 100% efficient luminaire. All of the light coming out of that lamp is going to go someplace and be used on surfaces around you. Some of it's going to go directly to your eye. The fixture down below, by contrast, with shielding and redirect and optics and all those things to push light where you want them to go, is probably trending down more like 50 to 60% efficient. And yet I would really submit to you that even though it's less efficient, it's more effective. It's less glary, it's pushing the light where you want it to be. So energy efficiency by itself is probably not the metric we really want to be looking at in our world. Energy effectiveness, by contrast, is a different kind of way to think about this, right? And the idea of energy effectiveness is not that we want to be profligate in our use of energy. That's exactly the opposite of what we want. But we want to use the least energy possible to meet visual goals, to get those critical perception tasks completed that we want to have, and to do it in a way that really is all about the quality of the light and the quality of the experience. We're creating buildings that people live, work, and play in 8, 10, 12 hours a day. It behooves us to be more interested in their experience than it does in strictly following a strict energy efficiency guideline. And we'll see some examples as we go through on that. But this is an excellent example, right? Here over at Microsoft, we've got a 27 square foot cube, right? That is internally illuminated, the big blue cube there. That has really basically nothing to do with the human visual system and everything to do with trying to create an experience within that space that emphasizes the vertical circulation and encourages people to walk up the stairs rather than using the elevators. Now, to be fair, it also, from a distance, acts as a civic beacon and draws attention into the building. But the point is to improve the experience of the space while doing it as effectively, energy efficiently as we possibly can, right? So let's go on to a couple of examples. This is a space that many of you will probably know. This is King Street Station. On the left, there was an energy retrofit. This was done in the 1970s. And there were lots of things going on in the 1970s. There were energy prices spiking. There was a lack of gasoline. There was a lack of a lot of energy at the time. Sound familiar? Well, this building that was created in 1906 by Reed and Stem architects, the same architects that did Grand Central in New York, had this beautiful, beautiful ceiling, and it was beautifully daylighted. It's a wonderful, wonderful building. However, it had a high volume, so the people at the time decided, how about we drop in this bizarre suspended acoustic ceiling tile, or 4 foot by 4 foot ceiling tiles, as I recall, and go ahead and light it with 8 lamp fluorescent light fixtures, 4 by 4 fluorescent light fixtures, and call it good. So they took an absolutely wonderful space, turned it into just this drab nothing, all in the name of energy efficiency, right? Let's make the space more efficient, less power for what we're doing in the space. Well, on the right, we rescued it. I was actually involved in 2 different design teams that were involving in rescuing this. One was a company called OTAC. We did a design first, and then it just kind of never went anywhere because there was questions about who was going to own the building moving forward. Fast forward, ZGF went ahead and did the retrofit, did a fantastic job. But looking at this, on the right, we have actually a very energy effective design, right? We're creating a space, it's much lower light level. If you took a light meter in there, there's probably a quarter of the actual light striking the floor on the right as on the left, but it has connection to daylight. It has abundant natural light coming in through those high clear story windows. I will be honest, we were lucky at the timing when I designed this initially. All of those historic decorative fixtures recreations were going to have to be halogen sources instead of the LED that they are now. But even so, we had another way to make it energy effective that we were going to use. But I think this is a real example of the trap that we can fall into if we are just looking at efficiency rather than the program of how we're going to use the space and why, right? Now, fortunately, we don't do things like this anymore, right? So here's SeaTac Airport. Some of you may have been down there relatively recently, I'm not sure. This is the north side of the airport, and this is the escalator banks down to the trains. Now, this is a double and in some places triple high space. The lighting design was recessed downlights with super specular, very shiny reflectors, and would have had metal halide lamps pushing light down because you had to push the light down to get to where you needed it to be. A retrofit's been done, I don't know by whom, but effectively what they've done is taken these, we call them corncob kind of LED lamps. I'm sure that the actual lumen package, the amount of light coming out of the bulb itself is probably pretty high. There's a lot of light coming out of there, but it's not going where we need it. It's not pushing light down to the floor the way that the original design had intended. It's just kind of blobbing a whole bunch of light into the space and hoping for the best. If you've been over there at night, it's absolutely abominable. This is an example of what not to do. Right? I hope nobody here was involved in this, but it's a fact. I mean, this is just the thing. So this is something that happened according to the idea that, well, let's save some energy. We're going to cut down the amount of watts that we're going to use, but we've completely failed at the program, at making the space one that we can use effectively. Now, new construction, in the 1970s and 80s, right, we had this idea that buildings had to be super efficient. And it's true, and it's a great thing. We love efficiency and all. But this is the Portland City building from 1982 by Michael Graves. And the brief for it was that this was supposed to be the most energy efficient building of its time. Okay, and it actually technically is, right? Graves did a great job at following that part of the program. Now, how did they do it? They made it very efficient by making a really thick building envelope that was kept heat transfer from going through. And they have these tiny little punched windows. So these tiny little punched windows, I'm all for windows, right? The more fenestration we have, the better. It gives you connection to the outdoors and all of those things. But if you look at the inside here, each of those tiny punch windows, they become not an amenity, but glare, right? They become something that you keep your eyes away from because the contrast of the wall to the ceiling to the window just is harsh. It's hard to look at. And the recessed lighting that was put in at the time, which thought it was pretty good, recessed parabolic troffers really doesn't do the space any favors. In fact, when this building was commissioned, was brought online, the people that were there immediately started calling it the world's tallest basement. Now, I was teaching a class in Missoula, Montana at one point, and one of the architects afterwards came up to me and used this building as an example and said, well, I was part of the design team for that building. I thought, oh no, I've just heckled your building, and I'm so sorry. He said, no. I just wanted to give you another anecdote that within a month of it being occupied, people were putting duct tape on the windows because they felt like prison bars. So this is an example of a truly energy efficient building that once again really fails at the basic program of being a place that we can spend time in, we can work effectively in. Just imagine how awful working in this particular office was, right? They have since done a significant mitigation on it, but this is a great example of following a program and still missing the target, right? Okay. Now, some of you may recognize this space. This is the old lighting design lab up on Capitol Hill after we renovated it for several reasons I don't need to go into right now, but the whole point to the lighting design lab, to give you a little bit of background, the Lighting Design Lab was a 2-year pilot project that was funded by Bonneville Power Administration, started in 1980, either 88 or 89, I always forget which. And there are people like Michael Lane, Diana Grant, and some others, Jeff Robbins. And the whole point of the Lighting Design Lab was to try to help avoid things like the Portland City building. The idea was to promote energy effectiveness over just energy efficiency, right? Because think about this, at that time, anybody who was in the industry then will remember that the energy efficiency world had, come out of the gate and was doing really great work, or so we thought, in saving huge amounts of energy. But we kept coming up with projects that people just didn't want to work in, didn't want to be in school in, right? Taking windows away from school kids, taking windows away from office workers, having dull drab lighting, having dull drab surfaces. We were really getting a huge black eye, and there was a lot of public backlash against the whole notion of energy efficiency because of it. So bringing in the idea of energy effectiveness centered it back on the people that would be working in the space. Yes, we're trying to save as much energy as we possibly can while still making spaces that people want to be in, right? Now, because of that, the Lighting Lab became the world's longest running 2-year pilot project. As Katie mentioned, it's now transitioning into the lab because they've added building electrification and some other briefs to the project, but it's still going strong because that is such a really important thing that people need to be first. All right. So one of the things that we did with the lab was technology, not just design, but also technology. So we went through metal halide, ceramic metal halide, T12, T8, T5, T2 fluorescent, a variety of different types of halogen. We showcased all of that stuff, right, within the lab. Now we came along, starting in the early 2000s, but really accelerating around 2014, 2015. Now we know that we have LEDs, right? And we can't really overemphasize the impact, right, on architecture that LEDs have given us. They have longer life, they have potentially better color, although that's not always true. They allow us to use advanced dimming systems much more easily than we've ever been able to before. We'll talk about that a little bit at the end. We can integrate more fully into architecture, everything really, for the most part, is better about LEDs than anything we've had in the past. And ultimately, there's nothing in the pipeline that looks like it's going to supplant LEDs. In the past, we've always had these evolutionary steps. There really is nothing in the pipeline that looks like it's going to come next. So, get used to these LEDs. But that's a great thing, because then we can focus less on the technology, right? We understand what we're going to use to light spaces from a light source standpoint and move on to how we're going to do it. So we can start with the notion of quality, right? So what is lighting quality, right? It's the old quip. I don't know what it is, but I know when I see it, right? So the IES defines lighting quality thus: they have human needs, economics and the environment, and architecture as this kind of tripod, with the intersection of the Venn diagram being quality. Okay, so let's look at these a little bit. Architecture, right? So what is in the architecture column? Well, it's the form, it's the composition, right? Codes and standards, to be sure, but really it's all about wanting to celebrate the built form and reveal it to us in ways that allow us to meet some of the imperatives that Bill Lamb told us about initially, but also give us some joy within the spaces, right? This is a library space in Saudi Arabia on that King Abdullah University project. It meets so many of Bill Lamb's requirements, but you'll notice there's one thing in particular, this one line of light up here, right? This is something that we basically are separating the ceiling from the wall and doing that as a compositional element to make the space frankly, feel brighter, right? Now, when we were building this, the contractors didn't want to put that up there because they felt that we were gilding the lily, as they kind of put it. But afterwards, when we had them look at the space with that one little line of light turned off versus one little line of light turned on, and that made an enormous difference in how people perceived the brightness of that space, because it had a little bit of glow within your field of view that separated those two planes, and for a very small amount of energy, really tied the space together, okay? Economics and the environment. Well, how easy is it to install and maintain and operate? How much energy is it using? I never ever mean to say that energy use is not important, because it really is, but it can't be the most important thing, right? It has to be part of this tripod. And of course, decarbonization, right? We were all trying to get less carbon into the built environment. But most important are human needs, right? Human needs visibility, right? How well can we see? What kind of task performance are we doing? Is the space comfortable? Can we see each other effectively? Can we understand our faces? Are the spaces making us happy, right? Physiology and circadian entrainment are also important. And yeah, again, we'll touch on those a little bit at the end, but not as much as perhaps I would like, right? But this is the most important thing. Now, there's another way to look at this. Peter Boyce, in the Journal of the IES a number of years ago, suggested that a very simplified way to think about quality and lighting, he came up with three categories. Bad lighting, the lighting system suffers from some kind of quality defect, right? And I should say these are somewhat subjective. Indifferent, the lighting system has no quality defects. Or good, the lighting system is technically correct and it excites the spirit somehow. Okay, so we have two images here. So before and an after from Agilent Technologies down in California. And the astute observer will note on the left that the engineer who worked in this cubicle has built a tent above their office space so that you can't, so it basically shields them from the harsh downlight of the 2x4 parabolic light fixtures there. This is what we did on the right, an indirect direct system with significantly less energy. We'll show some examples of this later, but I would submit to you that the image on the left is bad lighting And if we were in person together, I would suggest everybody raise your hand. Who thinks the one on the right is indifferent or good? Usually when I've done this with this particular image, about half, raise their hands for both. From my perspective, the one on the right is indifferent, right? And I can say that as one of the design team, that it's good, right? It's there's no quality defect. It's fine. It does what it needs to do, but it doesn't excite the spirit, right? How many people are going to go into that space and, ooh, this is great? Here's a different example, right? Here we have Lemieux Library before and after at Seattle University. It's the same stair, the same helical stair that you see in front of you, the same columns. Now on the left, we see, I think those were 4 or 6 lamp T8 or T12 recessed light fixtures. On the right, we see a complete redesign that emphasizes surfaces and visual needs, and frankly, I think is good, right? So we have on the left, I'm gonna say it's bad, right? On the right, well, some people could say the one on the left is indifferent, okay. But compared to the one on the right is good, right? It actually gives you some composition. It draws attention to places where you need it to be. It's a visually pleasant experience to be there, right? All right, so that's all great, right? How do we start to get from point A to point B? How do we get from just following efficiency to get to some of this effectiveness, right? It doesn't mean that we have to necessarily do, very zoomy architecture and very zoomy lighting like we have here on the left at the Hunt Library in Snohetta. It can also doesn't have to mean that we have to use, LEDs or super efficiency. The image on the right is a bar at the Pan Pacific Hotel in Yokohama that I designed in the early 1990s with halogen lighting. But I would submit to you that that's actually quite energy effective because it's very targeted. It's actually using relatively little energy to light a large area for a specific task to try to draw attention within that space. So until even today, it would be challenging to do this bar in quite the same way, even today with LED light fixtures. So let's start a little bit with the idea of vision, right? So how do we see? If we're talking to that sensation and perception psychologist that we mentioned at the beginning, who told us that 80% of environmental perception comes in through our eyes, they would probably break down the process of human vision. Last count, I think it was 27 individual steps, right, that I knew of. But for our purposes, we can break it down into simply 4 steps. Generators, modifiers, encoders, and interpreters. All of that really comes into effect when we're trying to interpret a scene like we see here. Now, we derive meaning from contrast and context in the visual field that we see around us, but also from our experience. If we look at this, we can see that, well, that's me in knee-deep powder, okay. But what is all that mishmash behind me? Well, if you have a certain experience, you'll understand that those are trees, right? And those are some kind of coniferous tree, and they've got snow on them. Well, if you've had the experience of skiing or living in a cold environment, you'll notice that all of that kind of fluff that's coming up behind me, that's powder. Well, that suggests to me that A, it's very cold there, and B, the snow is probably very dry, very fluffy. So there's a lot of meaning that I can derive just by glancing at this, all of which comes in from these 4 elements. So generators, very simple. It's a light source. Any light source. Could be the sun, could be a candle, could be a fluorescent lamp, right? Could be an incandescent lamp, whatever. It doesn't matter. What's more important to us, and I should point out, what people when they're beginning design really pay attention to is the generators. What is my light source and what is my light fixture? And that's exactly wrong. The actual tools that you use for energy effective design get chosen at the end, not the beginning. I don't care what the light fixtures are at first. I don't care what the sources are. What I care about are the modifiers. So what is a modifier? A modifier is something that takes light from a given source and does something to it. Typically that means reflecting, refracting, or absorbing the light. Now here we have the two most common modifiers that or two most well-known modifiers. The moon, of course, generates no light at all. It takes light, sunlight hits the moon. Some of that light gets absorbed, right, as heat. Some of that light gets re-reflected back to us. And that's what we actually see, what gets sent back to us. Some of it gets refracted, meaning scattered in the atmosphere. The ocean here that you see, light going into the ocean gets refracted by the water. Some of it gets absorbed by the water as heat. As it goes further down, the less active wavelengths, red, then green, finally blue, get absorbed. Right? So these are modifiers. They change the light around us. Now, again, sort of we might see this in, if I'm scuba diving in the water there, but to make it more practical for us, this is the REI flagship store in Denver. Now, all of the light within that space, that's all being provided either by daylight or by targeted accent lights on merchandise, hits those surfaces, the bricks, the merchandise, gets modified by those, and then gets re-reflected back to our eyes. So surfaces, the interaction of the generator light and the surface is critical, right? Now, the encoders, it's just our eyes, right? It's just the light coming back in. And we think of the eye kind of mechanistically as a camera, and that's reasonable, right? The eye is basically a vision producing organ. Right? Light gets directed back to a point on the retina called the fovea. And from there, an image is formed and runs through the optic nerve back to our brain to be processed. Now, I don't want to sort of denigrate the eye here. The eye is hugely important, and it's different from person to person. And I don't want to call it a camera because our cameras can see a couple of orders of magnitude of light level. Our eyes are so much better than any camera out there. We can see effectively over about 12 orders of magnitude of brightness, only about 3 at any given time, but it's incredibly adaptable. Again, a little bit beyond the purview of this particular class, but the most important part of this whole thing is the brain, the interpreter. How do we see the image? How do we interpret the image? The forms, the shapes, the context. Do we have a dark surface versus a bright surface, right? How we come up with all of these things is the most important. And I would submit to you that the core of energy effective lighting design is trying to use light on surfaces to paint a picture to tell your brain what you want your brain to believe. Do I want the space to feel bright? Do I want to feel dark? Do I want to feel open and airy? Do I want it to feel dark and contemplative? Am I most focused on somebody's face in front of me, or am I most focused on a shopping aisle, right? How we use light most effectively really determines that experience, and it's the brain that interprets it, right? So at the end of the day, energy effective lighting design is fundamentally integrating the visual field. It's taking everything that you see and ordering it, right? By putting light on it, taking light off of it, by changing the direction of the light, by changing the color of the light, understanding how we are going to perceive that space based on our experience and based on how our brain is going to interpret it. Okay, that's a whole lot of high level stuff, right? Let's circle back for just a moment and have a little bit of vocabulary refresher. So this, of course, is not a very basic class. And the assumption going in here is that you all know something about lighting, but let's jump back for just a moment. If that's not true, look on the Lighting Design Lab webpage and go to the Resources tab, and you'll find that there are a number of recorded classes that can fill in information that may seem unclear to you about some of the basics here. Particularly light sources, luminaires, and the design process are all great classes to that are recorded there that you can watch. So to start with, a lumen. A lumen, think of that as the pounds of light. How much light is a light source generating, sort of omnidirectionally, totally, right? A candela is that amount plus a vector component. So it's the directionality, right, of how light goes in. Now, the thing we all talk about in lighting is called the foot candle, right, or the lux. And that's basically how many candela are striking onto a surface per square foot or square meter, right? In the US, in imperial, it's per square foot. In lux, it's Système International is per square meter. Basically, divide by 10 is close enough. And the further you get from the light source, because we have something called the inverse square law, the further you get from the light source, the larger the area of that's being illuminated is, so the less brightness you have at any given point, right? So if I want, for example, I have a task light here, right? If I want something to be brighter, I bring the task light closer to it, right? I can use my general lighting in my office to get to those higher light levels if I want to, but it's much less efficient. It's more efficient for me to bring the source closer, right, when I can. I hope that makes sense to everybody. So a couple more kind of definition things. One is spectral distribution, or sometimes called spectral power distribution. This is how we can talk about how light sources will render colors around us. So light, of course, is, depending on who you talk about, it's either a packet phenomenon where photons strike our eyes and it's a particle phenomenon, or it's a wavelength electromagnetic spectrum phenomenon in which we have various wavelengths that correspond to red, green, and blue, or short, medium, and sort of long, medium, and short wavelength receptors in our eyes that allow us to perceive color. So how we perceive the colors of the objects around us based on the light that's striking them has everything to do with the spectral distribution, right? So how we are, what kinds of bits of the spectrum are involved in the white light that we see. Another way that we talk about this is something called correlated color temperature, CCT. And this is basically how warm or how cool we perceive the light source around us, basically white light. But imagine if you took a hunk of iron that would never melt and you kept heating it. If you heated it to 2700 Kelvin, it would glow much like an incandescent lamp. If you heated it to 5000 Kelvin, it would glow or incandesce very much like the color of the sun, right? That's where this comes from. So how warm or how cool the light source is, we tend to use these intentionally, right? In a residence or a relatively small space, we tend to use fairly warm light. In larger or places that we want to feel very clean and crisp, we use relatively cooler light, say 4000 Kelvin or above. Now, some of this is culturally driven. These are norms for here in Seattle. If we were in Korea, if we were in the Philippines, if we were in some other places, those might not be quite the same. Just understand that there's no hard and fast about this. Next is color fidelity, right? How well do the colors render around us the way that we expect them to with the particular light source? So we've all been there. We've been in a dressing room where we've been trying on, let's say, a brown sweater, and we get outside and suddenly it looks green. That's because the color, what we call the color rendering or the color fidelity of the light source, the spectral characteristics are different enough from the spectral characteristics of the sun that we perceive the colors differently, the colors that reflect back to us. So since the 1950s, color rendering index, which is a scale from 0 to 100, has been really the prime mover with respect to how we understood color fidelity. It's not a great scale. It has some problems to it. If you look at the reference sources there were originally 8, and they were all fairly muted colors, right? So the top would be 100 CRI, the bottom would be what it might look like with 50 CRI. So typically we wanted to have CRIs in the 80 to 100 range to ensure fairly good color. Along comes this extended range, including in particular R9. Everyone sort of thinks about this, that R9 means red 9. It really doesn't. It just means reference source 9, but it happens to be red. They added these additional colors to the test in order to give us some additional information. People always ask what the R9 value is, and usually you want the R9 value to be pretty high. Now there is a newer method called TM30, which is a much better method for evaluating the color rendition and the color fidelity. It gives you information about not only the rough fidelity, but also the color gamut, where is the color shifting, how are the metrics, and it uses 99 samples rather than 8, or the extended range, I think it was, what, 16. Now, I don't have the time here to go through this for you, but take the time, Google Michael Royer TM30, or just follow this link if you can from the handout that you'll get. Just copy and paste it in there, and you'll have about a 10-minute YouTube video of Michael Royer, who is one of the people most responsible for TM30, talking you through it and explaining why color fidelity metrics are so important, and how to go ahead and look at some of this stuff. All right, now the good news is with LEDs, we have huge ranges of possibilities with respect to color fidelity and what kind of color we might expect from various light sources, right? But one of the key things is you really want to do some mock-ups. So here's an example. This is the Tommy Bahama headquarters here in Seattle. When I was designing that, I wanted to make sure that the people that were designing garments understood how they were going to be looking based on the light that their customers would be seeing in dressing rooms and in their stores. So we actually did a mock-up at an all-day mock-up at their facility. And we had the designers come through, and I had half a dozen different light sources that they could play with, that they could look at. They could look at their materials under them, and they got to choose what particular light source they wanted. It turns out it was an LED source that had a CRI of 80 with an extended range of R9, right, of the red, that they chose. Now, that was interesting. We didn't have TM30 information at the time, but we do this all the time, right? At the lab in Soto, we actually hosted a mock-up for REI at one point when they were going ahead and testing for a new rollout of all of the accent lighting for their stores nationwide. We had them bring in a bunch of light fixtures and look at them on some of the textiles so that they could get a sense of what that would look like. Okay, so with all of this stuff, we derive perception, we derive how we understand the world based on context, contrast, color contrast, texture, luminance, illuminance, tone, tonality. We understand how we see these places based effectively, every bit of what I just said is based on how we light it, right? How we are bringing light into it. Whether it's looking at the library and lab buildings here on the left in KAUST, or this intentionally disorienting corridor over at Microsoft, this is how we see these things, right? And in particular, the proximate contrast is important, right? So this is just one of many examples we could bring in here. We've got two squares here, two blocks with gray centers. And of course, anybody who's ever done any brain teasers will understand that the intent here is that the gray is the same, right? But nonetheless, it appears different based on the context around us. That matters for how we view our buildings. There are times in which I can have 10-foot candles on a wall and it will feel bright. There are other times I can have 1,000-foot candles on a wall and it will appear dark. It's all about what it is around us and tying all of this information together, right? And it's also all about how we perceive brightness. So we've been kind of talking through some of this stuff, and I'm going to shorthand this a little bit, that really, let's just say, and in a lot of these kinds of classes, I will say that I'm being a little bit imprecise, and that's okay, because lighting design is a little bit squishy, right? So for our purposes, brightness perception, at least in the built environment, largely depends on light that is on the dominant surfaces that are around us. Normally speaking, that's the wall, right? Think about this. When you walk into a space, what are the surfaces that you most commonly notice? That's going to be the dominant surface. So in places like the Reno Convention Center on the right, that wall on the left is the dominant surface. It continues along the whole length, right, with the space there. And by lighting that, by intentionally grazing light down that, and having relatively little other light in that space, we make the space feel bright. If we took a light meter and put it on the floor and looked at how much light there was in there, it's probably much, much, much lower than you think, but the space feels bright because we're lighting the wall. By contrast, if we wanted the space to feel dark, we would avoid lighting the wall. I hope that makes sense, right? On the left, we have SeaTac Airport. The dominant surface in this view, dominant surfaces are the ceiling because it's a very large space, but also the window wall, right? So we wanted to make sure that we balanced the brightness of the surface next to the window wall, which is the ceiling there. So we have light gently washing up that surface so that it doesn't go dark by comparison of the window wall, right? Now, coincidentally, at night when that window wall is relatively dark, that light also then bounces down onto the structure of the window wall. So that becomes the dominant visual surface there, so that then it doesn't go completely dark. Right? I hope that makes sense. It's a different experience at night, but it's intentionally still trying to maintain that feeling of relative brightness without using an enormous amount of power. So the last thing that I will show you before we take a few-minute break is my wood shop. This is a story in several times. This is my wood shop. When we purchased the house that my wife and I live in now, we have a very big garage, and it was pretty much unfinished, right? You'll notice that there is Owens Corning bat on the ceiling there. It was really, really attractive and really fun. And it was there for a few years, right? So I built the wood shop out, and you know, we did changes to the house as we possibly could. But you'll notice that there's one set of perception going on here, right? The ceiling and the walls are relatively non-reflective. They absorb basically all of the light that comes to them. And there's a lot of lumens in this photograph. Fast forward a couple of years, I got around to throwing drywall up on the ceiling, but I haven't painted it yet, right? I haven't painted or mudded it, so it's still blue. And that's a different set of perception in that same space, right? The lighting is similar, but not entirely the same. Fast forward again till when I got a chance to drywall the walls as well and then paint everything, and it has a completely different perception, right? The biggest things that have changed from the first to the second are the surfaces, right? And actually, I will also say that the lighting is using half as much power, literally half as much power in the image on the right as it is on the left. It's the same space, it's the same time of day, right? I tried to take these photos sort of at similar times. my wall system is sort of partly done. But look at how different the perception is based on the surface and how light is interacting with that surface, right? The surfaces matter. Okay, I'm going to leave you with that for, it's 11:05, and I am going to say that if Katie has any questions, they can give them to me, but I will say that we have a 5-minute bio break while some of that stuff goes on. So if you need to visit the restroom, please go ahead and do so, and we will reconvene at 11:10.
Thanks, Shaun. We don't have any questions quite yet, but just to remind everybody as you go on your break, look for that question mark box and it'll open up a questions panel and you can type in there at any time.
Great.
Thanks, everyone.
So let me know if any come in, and otherwise have a lovely break. We'll be back in now 4 minutes. All right, I am now switched from coffee to tea, so hopefully everybody has had a chance to uh, um, do whatever they needed to do. Katie, are there any questions now?
There are no questions.
All right, good enough. All right, so everybody, welcome back. And we have now more or less concluded the um, background portion, right? Why are we here? How are we doing things? What matters? So if we move forward from that, once again, that's great, right? Where do we begin? How do we start to think about projects? How do we start to think about our spaces so that we are figuring out how we want to light them in such a way that they are energy effective and that they are taking care of the people that are populating them as best we can, right? Understanding that there are real world issues. Nothing's perfect. We all do the best we can, right? How do we most effectively try to wend our way through this? So the first step that I always tell people is analyze your project, right? Define the box. People always talk about um, thinking outside the box. Well, it's really important to understand what the box is before you can start to think outside of it, right? Before you can start to push the envelope. This may seem obvious, but I can't tell you how many young designers that have worked for me and people that really maybe not young designers who really don't start by analyzing their projects. A project comes to them and they immediately start thinking what kinds of light fixtures they're going to use, where they're going to put them, how they're going to use them. Really, that the tools come after. What you really need to do is go through critically and analyze your project, right? What are the space types? What are the visual tasks? What are the needs? What are the surface opportunities? What are the demographics, right? I'm going to approach a K-12 school very differently than I'm going to approach a VA facility in, say, Spokane, right? So are there special requirements? What's the budget, right? Budget's a big one. What are the owner's goals? And you may need to define those owner's goals for them. They may not actually know. What are the code requirements? I often hear about energy code being a big impediment, and I gotta say, I don't have a huge amount of sympathy for that anymore. With the exception of maybe a couple of typologies, the technology and the design concepts have moved forward enough that it shouldn't be difficult to meet an energy code anymore. So where else do we begin? Well, start at the beginning and ask yourself some fundamental questions, right? What are the critical visual tasks? Who's using the space? How are the users going to be impacted, right? What surfaces are important? When does the lighting need to be engaged at all? Sometimes it really doesn't, right? The wood shop that we see here, which is lighted with indirect, direct fluorescent lighting, that's an interesting choice for a wood shop, right? But it really provides a nice level of ambience and brightness and feeling within that space, right? It's going to have some challenges as well because you're going to have to clean the top of those light fixtures periodically, but it's actually really quite an interesting space. So what is the primary purpose for the lighting, right? Frequently that's work tasks, might be wayfinding, recreational, aesthetic. Usually there's some combination of tasks, right? So in this particular space at the Canyon Ranch Spa, there's two real tasks here. One is relaxation and the other is hydrotherapy, right? So one is active, the hydrotherapy is actually active, and the relaxation is very calming. So we had to come up with lighting that would work for both purposes. What are the primary tasks, right? One of those tasks might be being a dentist looking in a patient's mouth. If we spin that around, it might be the patient that's in the chair and trying to be A, not terrified, and B, not blinded by any of the lighting that you're being subjected to. Or it might be an industrial facility in which we're going ahead and assembling electronic components, for example. Where are the tasks? Are they vertical? Are they horizontal? We tend in the industry to focus really, 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 really on light striking horizontal surfaces. But that rarely has much to do with how we perceive the space around us, right? It's good to understand how light's distributing within space. It doesn't tell us a lot about how we're going to perceive the space. So where are the dominant surfaces? Normally speaking, in most areas, the dominant surfaces are going to be vertical, right? They're going to be the walls in front of you, as we see in these two images, right? Whether it's a stairwell that we see here, where we're lighting the walls rather than lighting down onto the stairwell, or it's like in this elevator lobby, it's the lighting the walls draws our attention into the space, so we move forward to where we need to be. We're not that interested in the ceiling that's there. We put a little bit of light down onto the floor, but most of the light in the space is on those vertical surfaces. So what are the dominant surfaces, right? The example on the right, Pacific Place, the dominant visual surface on the entry arcade from Pine Street was in fact the ceiling, based on the geometry of the space. So in order to make the space feel bright, we lit the ceiling. Now, there's not a huge amount of light in that space, but it is revealing the ceiling, so it feels bright to us. If you took a light meter onto the floor, it's not terribly bright, but it feels that way, particularly during at night. But during the daytime, it balances the brightness of the outside really effectively. It doesn't anymore, of course. They've done an interesting renovation since then, but that's what it was initially. Or at the Semiahmoo Resort here, dominant surfaces in this space actually was the ceiling. The ceiling was what drew from the open dining area to the enclosed dining area. Secondarily, we also have surfaces like the fireplace here. But what you don't see is that we also have targeted light for the dining surface up here. These are just decorative elements, right? So if you glance at them, those decorative elements help to fool our brains into believing that they're actually contributing to the light within the space, but they're primarily decorative. The light's coming from other areas, right? Lighting surfaces. So we have a fundamental toolkit, right, within the lighting world. And there are 4 dominant variables that we get to play with. The intensity, that's how much light do we have? How many lumens and what direction, right? What kind of light are we pushing somewhere? The distribution, that means where it's coming from and where it's going. So if we are lighting grazing down a wall, or if we're wall washing, those are choices, how we distribute the light within the space. The chromaticity is the color of the light. That either means literally colored light, or it might mean variants of white light, right? Warm or cool, how that goes. And then the surfaces. What are the surfaces around us that we're actually lighting? What is the texture? What are the colors? How specular, how shiny is it? Now, we do, of course, have the ability to affect distribution from the light fixtures, the luminaires that we choose, right? And some luminaires can give you lots of different options. This one particular light fixture from one manufacturer has a whole bunch of different ways that it pushes light outside of itself, so it can light wide ranges of ceilings, or close in grazing on walls, or lighting lab benches, whatever it happens to be. But choosing how we take light from the tool, from the light source, and push it to the surfaces that we are trying to light is really quite critical. So this is when you choose, once you've defined what your goals are, once you've defined what your surfaces are, what you want to have happen there, this is when you choose the tool and decide how you want to apply that tool, right? So at the end of the day, the whole distribution of light onto surfaces, kind of circling back, is really fundamentally tying the visual field together is what we do, right? So in this particular case, this is Reebok World Headquarters back in Massachusetts. There were a couple of key things that I wanted to do here. This is a connecting spine. It connects 4 different office buildings together, and has a lot of different functions going on. But one of the things you'll notice is that there's basically almost no light at all lighting the floor. it's all lighting surfaces. I have accent lights grazing up the structure. I have accent lights lighting the column knuckles here. I have accent lights lighting the building structure, and that's predominantly it. So I'm not spending a lot of time and money and energy lighting the floor, because lighting those surfaces, lighting the surround, does that for me, right? It gives me those Bill Lamb imperatives that effectively make me happy within the space, make it a visually interesting space without wasting a lot of energy worrying about the floor, right? Okay. Accent lighting. Accent lighting is a special case. Stanley McCandless, back in the 40s, who's a professor at Yale, came up with an idea to light the stage in which, if we wanted naturalistic lighting on somebody, we would have light coming in 45 degrees from nadir and from front, similar on the other side, and then coming in from above. So that kind of has been the basis of accent lighting forever. But there are some things, if we're going to light walls with accent lighting, if we're going to light those surfaces with accent lights, a couple things to think about. Typically, we want them less than 45 degrees. We want them, say, maybe 60 degrees, because we don't want to have people, if I think you can see my cursor. We don't want to have somebody getting close enough to the light fixture that they can look back and see glare in the fixture itself, right? So that's one key element. Another key element is what we call source task eye geometry. So here are two paintings that are from the Portrait Gallery, the National Gallery in Dublin. They're in different galleries, and they're lighted very differently. You can see the one on the left, the El Greco, is actually really quite clear when you're looking at it. The Caravaggio, unfortunately, if you're standing right in front of it, it has what we call veiling reflection, right? And what that means is the El Greco is lighted with accent lights from the sides, so that the reflection from the glass, instead of coming right back to the viewer's eye in the front, it bounces off away to the side, right? Whereas the Caravaggio has the accent lights from the front, so the veiling reflections bounce immediately right back to your eye. Now, if they took the light fixtures on the Caravaggio, spread them out, angled them in, you would be able to see it just as effectively as you do the El Greco. Now, there are other concerns potentially with accent lighting. Now, this is, again, the Tommy Bahama headquarters. This is a corridor. We lighted most of the corridors with accent lights on the walls. Again, lighting the vertical surfaces. One caution, this is a blow up on the right here of down a little further. We understood, we were very careful to get a good program of how the elements that we were going to be accent lighting, what was going to be there. So we designed the light accordingly, designed the distributions from the accent lights and so forth, and then focused them accordingly. And what actually happened in real life was completely different. So as you'll notice, there is oddities down here about lights on walls, and it just didn't turn out to be. This is not a great accent lighting project, and it could have been, but things changed at the last minute. And we didn't really have the ability to adapt with it. So be careful with accent lighting, right? Versus if I was going to do this project again, I would have done wall washing instead of accent lighting, right? Okay. Chromaticity. Chromaticity is, of course, the color of the light, right? It's the spectral characteristics. On the left, the light is relatively warm. It's probably in the 2700, maybe even warmer range, except the pool light. The pool light is probably 3500 because we wanted that to be a little bit bluer in there. But we've chosen very carefully for the program what color or what chromaticity of light we wanted. On the right, This is a very, very low light level. It's actually a blue LED that's being reflected through this water tank. There's a mirror on the bottom, and it's intentionally, literally blue for this particular purpose. It's also probably, if you took a light measurement in there, it's probably like 0.05 foot candles. It takes a long time for your eyes to adapt to within this space, but we're choosing intentionally based on the program. Now, we might choose intentionally based on things like circadian rhythms, right? Or human alerting functions based on what we're learning for with respect to the endocrine system and human physiology with respect to light. So that's also an option. Now, surfaces, we kind of skirted around this. The surfaces are, in my estimation, the single most important part of any lighting design, right? I can throw lights in the ceiling, I can do whatever, but it's the surfaces that make the space sing. This, of course, is SeaTac Airport. We did the renovation of SeaTac in 1998. And the dominant surface in here is, of course, that bulkhead that is currently clad with maple. When we started this project, that was clad with a really dingy gray fabric wrapped panel system. We actually hired the lighting designers. We were the prime on this project. We hired Weinstein Copeland to clad this bulkhead with something that we could light continuously so that it tied the entire project together, right? So we were looking for that particular surface. Now, sometimes those surfaces are really not so great. This is the federal courthouse downtown. You'll notice that we have a brown wall here that's sort of being lighted, and we have a polished dark marble wall here that literally can't be lighted. Polished surfaces don't catch light. So this, from a visual standpoint, is never going to be anything but a dark hole that is going to feel ominous. And the photo on the right is the same space from a different direction, and it's intentionally photographed in such a way that it's similar to the way that your eye would perceive the space. Because there is so much brightness coming in from this window wall, and because the walls themselves don't light very well, it feels very dark and ominous because you can barely tell those people that are there from this direction, right? From the photo on the left, you can look back and you can see in there because the light's coming from the other direction. In the photo on the right, people are silhouetted. So choosing surfaces, please, 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 please don't do shiny walls. Shiny walls bad. This is an example from the Lewis and Clark High School over in Spokane, where they came and they said, well, we need better lighting. We need more lighting because it's too dark in here. The reality was, if you took a light meter onto the floor, they had abundant light. But from a perception standpoint, the walls and the ceiling are painted. It's a little bit hard to tell, but you can see this fellow's t-shirt is white. This is a dark cream color. They chose intentionally to paint the walls and the ceilings this dark cream color because those are the dominant surfaces, the walls and the ceiling in this particular case. No matter what you do from a lighting standpoint, it's going to feel dark in here, unless I suppose you actually wash the walls and light themselves, but that's not practical. So the lighting retrofit here was to paint the walls and the ceiling white. Similar choice. Excuse me, I'm going to turn off my mic for 1 second. Similar choice, this is the Scottsdale Fashion Square. We worked on this some years ago with Callison, and we didn't do the lighting in the parking garage here, but they wanted us to relight it. And we looked at it and we said the lighting at the time is fine. What you need to do is paint at the time, these were dark gray panels. We had them paint the surfaces in there without changing the lighting at all. The space looked and felt much brighter and actually had a higher measured light level. But understand that the reflectivity of surfaces may not be what you think they are, right? People think, for example, that wood surfaces reflect a lot. This maple that you're looking at here from the Reebok World headquarters, I'm going to say that's 40 to 50% reflective, right? Brick, much less. Acoustic ceiling tiles, a really good one, maybe 90% reflective. So you're absorbing a lot of light no matter what you have, but the surfaces getting the light onto them, at least revealing them. You don't necessarily have to bounce light off of them, but revealing them is critical. All right, so those are some of the key elements. How about looking at some actual practical tips here, right? When you're working on a project, start with daylight. Daylight is what we are evolved to see. It'll save you energy, it'll make people happier. We know that it makes people more productive and learn better, right? But also we know that if we've got daylight in the building, in almost all cases, we can see the horizon so that we can actually let our eyes relax when we do that. That's very important, right? Being able to see outdoors and also have that connection to nature, just like Bill Lamb told us so many years ago. But when you do start with daylight, make sure you're doing it in a way that you're testing. You're making sure that you're not causing problems, right? This is the 525 Golden Gate down in San Francisco. It's the headquarters of the San Francisco Public Utilities headquarters. We designed this building in such a way that all four cardinal directions are different because all four have different relationships to daylight. On the north side here, you'll see that it's basically big open windows because you really don't have a lot of sun penetration there. On the east and west, we have predominantly circulation and private offices that can be easily dealt with. On the south side, we have this multi-layer overhang system that allows us to prevent glare, prevent solar heat gain, but also redirect some light from the outside into the ceiling of the interior as if they're kind of like light shelves, right? Some of them also have photovoltaic panels on them, which is quite useful. But you got to test that, right? We went through multiple iterations with the daylighting lab, in particular doing physical modeling, and made sure that the building was going to perform the way we expected it to. But somewhat more prosaically, well, here's the Bullitt Center, right, up on Capitol Hill. Look for opportunities, right? This is one of the most effectively daylighted buildings I've ever worked in. Part of that is that because we were doing daylighting, we asked the city, SDCI, for a variance on the floor-to-floor heights, and we got it, right? So if you look here, we have very tall ceilings. The higher the ceiling, the deeper the daylight penetration is going to go. If you don't ask, well, you're not going to receive. Now, I know there are some folks out there saying, hey, that's great for new construction. Well, here's an example of an adaptive refit, and this was an adaptive refit from 2000 or so, 1999. So this is not new. We showed you this example before of accent lighting surfaces, right? Choosing what to light targeted wise. But this was the old power station for the Denver trolley system. And it's a historic building. One of the things that we wanted to do from the get-go was improve the daylight performance. So as you can see, there's already clear story windows. There's already walls here, right? They're here and here. But that wasn't providing enough daylight that we wanted to have within that space. So we proposed and did some modeling and got buy-in from the historic folks that what if we pierced the ceiling and we put in a series of skylights on the north side, and then at the climbing wall, we have a skylight on the north and the south, so that we would in fact have some solar gain coming through there to give a little bit of natural variability during the day. Worked out really, really well, right? But this is an example of buildings that you can effectively daylight. In fact, Joel Loveland used to tell us the actual stat, and I don't remember, but it was something like more than 50% of all buildings that are west of the Mississippi are either two-story or within 15 feet of a window wall. So most of that space can be effectively daylighted, right? Choose to direct attention, right? Use composition in your favor. If you are trying to direct attention, for example, to this sort of social conference area here at the Bravern, do it with lighting, right? Do it with lighting the walls, do it with adding decorative components. At Rainier Vista on the UW campus in the top here, the primary goal is wayfinding, right? So instead of putting big poles here, we actually put handrail lighting in that lights the vertical surface of the fencing, but also then provides a pathway for your eyes to follow that brings you right along the wayfinding route over to the Husky Stadium and to the light rail station, right? So rather than putting in poles, rather than putting in something that's uses a lot of energy to light a big area, we're actually lighting a pathway. Or here at the Canyon Ranch Spa Club, right, we're using a small amount of light to make this onyx system glow to draw your attention into it, and then highlighting it with the radial pattern of the lights here that all serve to draw your attention to where it needs to be. But they don't have to be sort of big zoomy things like this, right? We can use lighting in gondolas, lighting in supermarkets within the space here to direct attention. And conveniently with LEDs now, all of these things can have their own individual occupancy sensors. We've all seen this late at night. We walk down the frozen food aisle and the lights turn on as we get to them. That's fantastic. That works really well and energy effective, right? Targeted variability, right? So we don't have to light everything evenly. In fact, we don't want to light everything evenly. We want to have episodes of brightness and relatively darker areas, relatively brighter, relatively darker, because our eyes and physiology are adapted to see change, right? So choosing wisely where to put the light and where not to put the light saves an enormous amount of energy, a good amount of project dollars, but it also works better for our visual systems, right? Now back to SeaTac Airport. I use this example a lot because everybody's been through here. The image on the left is what it was before we got there, where we had lines of light with very high output T12 fluorescent lamps. On the right, we are lighting the surfaces, right? So on the left, we're doing what I call volumetric lighting. Some people say volumetric lighting and think that's a good thing. Sometimes. Most of the time, I would prefer to choose surfaces, light those surfaces, and then move on, right? So you'll notice that there's relatively little light in that space on the right other than the wall wash, and then occasionally at the perimeter, where there are actual task areas, we have those linear fixtures that kick some light up onto the ceiling, some light onto the floor. Now, from an energy standpoint, we actually saved about 60% of the energy within this space. Still fluorescent, a different flavor of fluorescent to be sure, but I mean, we're still talking about fluorescent. We're not even going to LED at this point, right? So think about that. We've come up with a space that feels better, looks better, feels brighter to us than the old space did, and yet is using 60% less energy. And the actual measured light level on the floor, which is, we're all taught to look at foot candles, is a fraction of what it was on the left, right? If we extend that to the outside, we did something very similar outside. Of course, they're changing this now, and that's good because, again, this was 1999. So it's time for another refit at this point. But the whole point is that putting the light where you want it is really more effective, right? Even from a distance, than just kind of blobbing light in the space and hoping for the best. Now, use lighting layers, right? Choose when you're starting to think about some of these places after you've analyzed your project, think about what kind of layers of light you might actually have within your space. Sometimes you're going to have all of these, right? In this particular image in a lobby over in Bellevue, every single one of these bits of lighting layer scheme is used somewhere, right, on this project. And it's a very comfortable space. It uses composition to draw your eye into the space down to the elevator areas. I think it's very successful, right? And it's relatively low energy use, right? Because it's lighting those surfaces. Again, we're not trying to put a huge amount of light onto any horizontal surfaces, we're trying to reveal the architecture around us to create a perception of brightness. Here's a retrofit example, which is Miller Hull Studios here in town, right? It's a Polson building in Pioneer Square. This is what it looked like initially. Had incandescent accent lighting and linear fluorescent light fixtures everywhere. The biggest thing was that it had one lighting control zone. You walked in, you turn the lights on for the entire floor plate, right? It's one whole floor plate of this building. There was no ability to, you could have one person working on a Sunday and the entire place had to be lighted for that one person to work. So when we did the retrofit, we opened it up. We made sure that we all had daylight, access to daylight and view, right? Again, brought daylight in as best we could. We couldn't, of course, increase the floor-to-floor height, but it's already fairly generous, right? We changed it to high-performance indirect direct LED luminaires and added lighting controls so that they would dim when there was abundant daylight available. And they would be able to turn just a few lights on or off based on who was there so that they didn't have to have the whole floor plate done. We used a networked lighting control system with wireless sensors and distributed controllers, wireless switches. So the installation was quite easy. So we had better lighting controls, much happier staff. And we went from 1.05 watts per square foot down to 0.3 watts per square foot. So it's an enormous energy saving. Some of that is based on the technology. Some of it is based on the fact that we are not trying to light the horizontal plane as much as we're trying to light the surfaces within the space to give you that brightness perception. You add in the controls, we're probably down to 0.15 watts per square foot, right? So even though we aren't focused on the energy efficiency, it comes along with the energy effectiveness. Contrast. I have mentioned that we do want to have variability, but we do also want to make sure that we're looking at, when it matters, contrast. This is a good example of the molecular engineering building ZGF did over at UW campus. The most interesting thing here is the lab benches are gray, right? I always try to get people to do things like gray lab benches instead of black, because keeping the visual, keeping the brightness on the surfaces around us within certain ranges, at least in high task areas, makes it much easier for your eyes to perceive things properly. And the only reason people like to use black lab benches is history, and because when reagents spill on them, they're easier to clean. But this makes for a much more visually pleasing space over time. Okay, make sure you have daylight controls, right? So this was my office in the Bullitt Center. Same space, but at night, during the daytime, the lights are dimmed way down, right? At night, when Tony is here working on a Sunday afternoon, when I'm in here taking this photograph, and Mitri is down working down here, you'll notice that only the lights that are around them are on. Everything else is turned off. Critical. Okay. So back to the Lemieux library, some examples of this. We've seen this where we had the double helical stair. We got rid of the volumetric lighting in there. We added in surface lighting at the back. This compositionally draws your eye through the space so you see the whole space. We have accent lighting on the painting here, which helps on that same thing. We do have some down lighting, right? And we have these candles, I call them, hanging from the ceiling. They're providing some light within the space, but they're also providing something visual for you to latch onto and think, oh yeah, your brain interprets this as the space being relatively bright. Of course, the measured light level is a fraction, but it's a much more comfortable, much more interesting space to be in. To be sure, the surface changes, the column covers, the back wall, those things are all critical. That's part of my point. You can't have high quality lighting without high quality surfaces. You have to look at both of them together. It's part of one gestalt, right? Now, a much more prosaic example from within that space is the library stacks up above, right? On the left was before, on the right is after. So on the left, they had a pattern of don't remember if they were 2-lamp or 3-lamp, but they were very bright fluorescent light fixtures just scattered throughout, again, blobbing light everywhere, hoping for the best. We got rid of all that, and then we put linear indirect directs down the stack rows so that we kick some light up onto the ceiling, but most of the light is going onto the book stacks with a specific distribution of light meant for book stacks, right? So using a tiny fraction of the energy, but it's visually more pleasing, right? Again, same space, right? This is the study area at the Lemieux Library, same kind of space. We've just gone to the end of the stack here. And on the left, before, on the right, after, instead of continuing this fluorescent blobbing of light, we just put in some wall washers, lighting the walls themselves, which balanced the brightness of the window walls, which is good. Gave the space a feeling of brightness overall. Again, a fraction of the measured light level, but feels brighter, feels happier, and works better for the task. Some of the carols, not all of them, but some of them had task lighting associated with them, so that if people needed higher light levels, they actually could find spaces that had them. Agilent technologies, we saw this earlier, right? Where we had high surface light levels shooting down from the parabolics. In fact, so high in some cases, people felt that they needed to hide from them. When we retrofitted it with an indirect direct solution, much lower light levels, right? Much lower measured light levels, but the space feels tremendously brighter because the dominant surface, the ceiling, is lighted. Now, some of these photos, apologies, they look a little stripy. In person, it really isn't. This is one of the downsides of early digital photography. The glare is gone, no more cubicle tents, and again, a small fraction of the energy being used, right, within this space. It doesn't have to be places like this. It could be hospitality spaces, Semiahmoo Resort. We're selectively targeting surfaces to light, in this case, the ceiling, right, to give some perception of brightness. And that changes during the day, right? This is close to dusk when the ceiling is still a little bit brighter. Later on in the night, the ceiling fades away so that you're focused much more down rather than in the space, but we're lighting the ceiling to balance the fact that there are 3 sides of this bar that are complete window walls. Similar in the Yokohama bar here, right at the Pan Pacific, we're using MR16s to light the tables and nothing else. So it's still halogen, but it's actually quite energy effective. We do, of course, light the center here so that people will focus on the bar as they need to, but again, that's part of it, right? Okay. So some examples with LEDs, we can do this very effectively, both with color, but also with directionality and very small tucked in light sources, right, as we come through. But we do need to pay attention to the fact that LEDs are not a panacea. Now, this, of course, is University Station. This was a retrofit. This is very similar to what we saw at the SeaTac Airport, right, the North Terminal. Somebody took these LED screw base retrofit lamps, put them into a reflector that is meant to be pushing light down, and of course we get this really annoying pattern on the floor. The point to this space, the number one reason for this space, is wayfinding, getting from point A to point B. Does this patterning help with that, or does it harm with that, right? So I'm sure some energy was saved here, but the actual effectiveness went down significantly. It's another example. This is energy. This is Pioneer Square Station. And at the end of the station on both sides, there is a clock. You can't really tell that it's a clock here. It was actually quite an important art piece, the clock on both sides. And there had originally been some high intensity halogen light sources, accent lights coming from, hope you can see where the spot is here. Those are retrofitted to LED instead of halogen. So now what you can see, instead of the clock, you can see some light here on the surfaces that doesn't help anyone. And you can see glare coming from those LED lights instead of lighting the clock. So I would submit to you that in this particular case, this is an absolute waste of energy, right? So energy may have been used, may have been reduced, but the base program is no longer being met, right? From a visual standpoint, that you can no longer see the clock, the art piece is no longer being lighted. So if you're going to do that, then just turn the things off entirely and accept the fact that you're not interested in the program anymore, rather than doing something that just doesn't work. Okay, so that's some bits about lighting. What about lighting controls, right? Lighting controls are critical in any of these projects. Now, I like to think of doing a building without lighting controls as kind of like playing a piano that you never tune. You really need to look at all of these strategies that we have here and figure out how they're going to apply on your given project. This again is the San Francisco Public Utilities headquarters. Every single one of these typical control strategies is used on this single 14-story building somewhere. And that's common, right? You have a lot of different types of spaces that have different needs. This used to be complicated. Now with network lighting control systems, and in particular the subset luminaire level lighting control systems, if those sound unfamiliar to you, again, go to the Lighting Lab website, and there are lots of resources there about both, and classes that I've taught that are recorded that you can get more information on those. But as a quick case study to let everyone know that City of Seattle is trying to walk the walk here. We did a retrofit of the general lighting that's ongoing for the Seattle Municipal Tower. We had recessed high performance fluorescent T8 light fixtures with almost no real lighting controls, to be honest. But the replacement luminaires are no longer available. So we hosted a mock-up review in 2019 at the Lighting Design Lab, and we selected a luminaire that we all chose was the correct one, and we assumed that we would use, again, luminaire level lighting control. So basically, every light fixture has its own sensors, every light fixture is dimmable, and so forth. So based on the retrofit replacement with the existing versus the retrofit luminaire, the luminaire savings alone was estimated to be about 43% savings, still having pretty good visibility, visual lighting, with estimating the lighting power density down at about 0.4 watts per square foot. When we added in the lighting controls, right, the savings was even higher. So the estimated overall savings for controls in that was going to be 60% savings, with each floor saving 29,000 kilowatt hours per year. So this is a big deal, right, from a savings standpoint. But the energy savings isn't necessarily the way to sell these to your owner. Why do we use lighting controls, right? This is the list of why I choose to use lighting controls in projects and how I sell them to my owners, right? I try to emphasize the non-energy benefits, which are frankly more important than the cost these days. So flexibility, right? I want to be able to make sure that I can adapt the lighting as necessary in every space that I occupy, right? That might be dimming in a classroom, that might be dimming in a private office, that might be occupancy sensors, whatever it is. productivity. The ability to tune the lighting to each of our choices when we can is incredible. People really love that, right? People have user satisfaction when we get to choose the light levels that we want. Maintenance. When we dim light sources, we reduce the energy going to them, we reduce the heat associated with them, they last longer. There are a variety of sustainability programs. If you have any sustainability aspirations at all, you must use these days, realistically, networked lighting controls or luminaire level lighting controls or both. The energy savings are really quite well understood, right? So this is the table from the Bonneville Power Administration. It may be updated by now, that, for example, City Light will use when you go to them and ask for a rebate. This is what they will use to assume how much energy savings your project is going to have by using specific lighting control methods, right? It's very well understood, but the problem is too many people, when you're talking about lighting controls to your owners, will go in talking about the energy savings first. The energy savings is a byproduct. You want to look at the non-energy benefits first, right? And energy codes, right? The good news about energy codes, you have to meet them. So you really, really, really don't have to talk to your owners about why necessarily in some cases you're going to have a base level of lighting control. It's required by code. But you do want to bring them on board with the higher functions and why it's important to them to look at better systems rather than just base level systems. There, of course, are other things. Now, for light and health, again, there's a lot going on out there. There's a huge amount of research. Lots of people are taking it seriously. The key thing here is that the key stimulus variables that are in play for the circadian systems and for the light and health, 3 of them are also the top 3 variables for human-centric or energy effective lighting design. So they actually go hand in hand really well, as long as you remember that you also need to have the lighting control system, the advanced lighting control system, that allows you to make those changes, right? There is a recommended practice from the IES that is available for the physiological and behavioral issues with respect to interior lighting. Again, apologies, we don't have time on this class to get to it, but that's what you got. So with that, that's my general story. Are there any questions? Katie, any questions?
Hello, yes, we've got a couple.
And I hope, by the way, that this is useful for everybody. Also, in particular, before Katie gets to that, if you have feedback, you guys are the first people to see this particular class. If you have feedback, do share it with Katie in the questionnaires so that we get a sense of how we can make this better for each of you, right? I'll talk about lighting all day long, but the whole point is to hopefully help you in your practice. All right, so Katie, sorry.
No problem. Now, before I've just got 2, but I want to say really quick, I kept getting it looked like a notification that I was getting a question and then there wasn't anything there. So if you typed a question and it's not in either of these 2 I'm going to ask, try typing it again and see if it'll come through. Okay, so first, in the Lemieux library example, when wall reflection replaced the fluorescent lineals, were the former retained above the perpendicularly positioned book stacks, or was some type of linear lighting provided above and along the spaces between the stacks?
No. So all of the existing, at Lemieux, all of the existing lighting was removed. Everything was removed. So within that space, within the stacks that you're talking about, there is only, in that particular area, there is only the light that aligns with the stacks. So it gives uplight to light the space in general, but also then light down onto the stacks. And then at the ends of the stacks, at least on the side that I showed you, we're just lighting the wall. We're not lighting down at all, right? There are other areas on other floors where it's a little different, but in that particular case, that's how it was set up.
Okay, and then Byron has a question he's not sure how to ask. I've seen that fixtures have quote unquote bulbs or luminaires. There's maybe a terminology question, are built into the fixture. When the bulb fails, the whole fixture completely fails and needs to be replaced. How does the owner cope with fixtures changing so rapidly as opposed to just changing bulbs?
Yeah, that's a fantastic question, and it's one that the entire industry is grappling with. So at the beginning, and it's interesting that you asked that because some of the questions that you're asking were ones that we asked actually during the design of Lemieux. We were asking manufacturers since, at least with luminaires that have the LEDs already baked into them, how do you replace them, right? How do you know, if the board goes bad, or more likely the driver goes bad, if the driver goes bad, it's like replacing a fluorescent ballast. You just replace the driver. If the board itself goes bad, then you get a problem, right? That does the manufacturer have an ability to get into the fixture and replace the bad board? Do they have boards in stock, right? Are they going to have boards in stock 5 years from now or not? So the entire industry, in fact, my former company, Luma, one of my former companies, had done some research that they presented at Light Fair on this. You might go to their webpage, look for Luma Lighting, and they probably have a link to the report that they found with respect to these kinds of issues. And the reality is that it may be that some high-end manufacturers do have the ability to make changes, to add and replace boards, but you know, when you're talking about commodity grade products, you know, you're talking about a project that has 1,000 2x2 inexpensive luminaires. When it goes bad, it's coming out of the ceiling, and you're right, it's a problem. And it's a problem we haven't really fully come to grips with in the industry, but we do understand that it's a problem. I wish I had a better answer for you.
And that's all the questions we have right now. I'm going to give it a couple of seconds and just note here the slide Shaun's got up. There's his contact, Avery's contact, if you have questions on those incentives. If you have any questions about any kind of projects and are looking for funding, that email and phone number are your best friend. And then the lab at City Light, our email address has shortened a little bit to thelab@seattle.gov. And when we close out, please take that survey. You can note in there how much you liked Shaun's new class, what you're going to apply to your everyday, and we'll pass that along to him too.
And I will add, I will echo what Katie said, a little plug. Particularly if you're doing a retrofit project in Seattle, if you're doing any kind of retrofit project, or even in other locations, it's worth taking the time. A lot of designers don't do this, and that's unfortunate. It is worth taking the time to engage with City Light or PSE or Snowpod or whomever, and try to get some help with the projects that you're doing, particularly with lighting controls, right? Most utilities now will in fact offer incentives for advanced lighting controls. So yes, I think it's important to lead your discussions with owners with the non-energy benefits, why this matters to them, right? Beyond the dollars and cents, why it's going to make it a better space, why the people will be happier, they'll get better productivity. And that doesn't matter whether it's a bar or an office building. You're going to get better productivity with better controls, period. But you can, in some cases, get frankly, the cost of most of your controls paid for if it's a retrofit project. So that's important. All right. If there's no more, well, go ahead and email me if that's helpful. And otherwise, then I will say thank you, Katie.
Yeah,
And
thank you
let
for
me. Whoops.
the official thank you slide.
Whoops.
You're getting
There.
claps. I hope you can see the claps. All
I
right.
do. I do hope this is useful. So, but again, do um, uh, do send feedback to Katie. It really is helpful for certainly for me, but it's also helpful for the lab to know what kind of programming will be useful for them and
Yep.
how people are best served. Because I mean
Yep.
that's the
What
goal,
do you
right?
guys need to know? Yep. Thank you so much, Shaun. Always glad to have you, and we will see everybody at the next, the envelope webinar is what's up next. Bye, everybody.